Here we are looking at one of the series that we have seen earlier is the sum of 1 over n, where n goes from 1 to infinity, and it's just the sum of 1 plus a half plus a third plus a fourth plus a fifth and so on. This series has a name. It is called a harmonic series. This harmonic series belongs to another class of series called the p-series. The difference is that when we talk about the p-series, my n can be raised to a power. So it's going to be 1 plus 1 over 2 to the p, 3 to the p, 4 to the p, 5 to the p, and so on, where my p is going to be a variable. Now then, notice that this p-series is going to differ from the geometric series that we have seen earlier, in that the variable is going to be in a different place. For example, if I have the sum of, let's say, 1 over 2 to the 1 plus 1 over 2 to the 2 plus 1 over 2 to the 3, 2 to the 4, 2 to the 5, and so on. This is going to be a geometric series. Geometric. But if I have something like 1 over 1 square plus 1 over 2 square, 1 over 3 square, 1 over 4 square, 1 over 5 square, and so on, this is going to be a p-series. Note that in the geometric series, my base stays the same, so it's just going to be the same base 2 here, but my exponent changed. So my exponent changed from 1 to 2 to 3 to 4 to 5 and so on. But when we have the p-series, the exponent now stays the same. So the exponent is always going to be 2 here, and then my base is going to change 1, 2, 3, 4, 5, and so on. And that's going to be what happens here. My exponent is going to be p. So it's going to stay the same, but my base is going to change from 1 to 2 to 3 to 4 to 5 and so on. Notice that the harmonic series is actually just the p-series when the p is equal to 1. So here it's going to be just 1 over 1 to the 1 plus 1 over 2 to the 1, 3 to the 1, 4 to the 1, 5 to the 1, and so on. Now this p-series is going to converge when p is bigger than 1, and this is going to diverge when p is less than or equal to 1. So for harmonic series, when the p is exactly 1, it's going to belong to the latter class when it is going to diverge. So this guy is going to converge when p is bigger than 1 and diverge when p is less than or equal to 1. So let's take a look at the example down here real quick. So the first one that we are looking at, this is actually just the harmonic series. Or it's just the p-series with p equal to 1. So this guy is going to diverge. For the next one, 1 plus a fourth plus 1 over 9 plus 1 over 16 plus 1 over 25, we can see that this is 1 plus 1 over 2 square plus 1 over 3 square plus 1 over 4 square and 1 over 5 square and so on. So this guy is a p-series where the value of my p, the value of my exponent, is going to be 2. So this is a p-series with p equal to 2. And because 2 is bigger than 1, so this guy is going to converge. This guy is going to converge. Okay, for the next one, I have 1 over square root of n. Notice that the square root of n is actually the same as n raised to the 1/2 power. So this is the sum of 1 over n to the 1/2. So this is again a p-series where the value of my exponent p is a half. So this is a p-series with p equal to 1/2. And because 1/2 is less than or equal to 1, so this guy is going to diverge. Notice how the answer to this 3 part should make sense, because if we think about it, 1 over, so this guy is the sum of 1 over n, right? This is the sum of 1 over n squared. This is the sum of 1 over the square root of n. But 1 over n squared is smaller than 1 over n, and this guy is smaller than 1 over the square root of n. So if we sum this guy, let me actually kind of rewrite. So I have 1 over n squared this guy is going to be less than or equal to 1 over n. And this guy is less than or equal to 1 over square root of n. So if I sum them up, the sum of 1 over n squared should be the smallest, and the sum of 1 over square root of n should be the biggest. So it makes sense that this guy converges while this guy diverges. And because this 1 over square root of n is even bigger than the sum of 1 over n, and this guy diverges already, so this guy should also diverge as well. And that's what we found out here. And now for the last example, this is actually a trig series that we won't see often. This guy actually has a name. It's called a telescoping series. It's basically a series where things are gonna get cancelled out, so it's gonna be easy to simplify. So if I were to write this guy out, let me actually write out the sum first. This thing is going to equal to 1 over n times n plus 1, right? And my n starts from 1, so it's gonna be 1 over 1 times 1 plus 1, which is 2. The next term is going to be 1 over 2 times 2 plus 1, which is 3, plus 1 over 3 times 4, plus 1 over 4 times 5, plus 1 over 5 times 6, and so on. Now, there is actually a way that we can write each term that we are looking at here. 1 over 1 times 2, this is actually going to equal to 1 over 1 minus 1 over 2. 1 over 2 times 3, this is 1/6, so this is actually going to equal to 1 over 2 minus 1 over 3. The next term, 1 over 3 times 4, this is going to be the same as 1 over 3 minus 1 to the 4. 1 over 4 times 5, this is going to be the same as 1 over 4 minus 1 over 5. And the last guy, this is going to be 1 over 5 minus 1 over 6. And generally, if you think about it, if I have, let's see, 1 over n times n plus 1, this is actually going to equal to 1 over n minus 1 over n plus 1. And this is because if we compute out the right-hand side, if I subtract these two terms, my denominator is going to be n times n plus 1. I cross multiply, so I'm going to get n plus 1 minus n. N plus 1 minus n is going to be left all with 1. So I'm going to have 1 over n times n plus 1, which is the same thing. So 1 over n times n plus 1, by some coincidence, is actually just going to be 1 over n minus 1 over n plus 1, which is kind of what we did here. But now notice that the terms in my series get cancelled out. The negative 1/2 and 1/2 get cancelled out, negative 1/3 and 1/3 get cancelled out, negative 1/4 and 1/4 get cancelled out, and so on. So then, after all, I'm going to be left with 1. So this guy, part D now, is going to just converge to 1.